Hello and welcome to this lecture on the analysis and interpretation of quantitative data. At the end of this lecture, you should be able to analyze and interpret quantitative data and reach reasonable conclusions. So, quantitative data analysis involves systematically examining the evidence that is collected in answering a specific research question. It is a process of sorting and categorizing data using the appropriate tools and approaches. The third step of the participatory model of evaluation is to analyze and interpret the data. This lecture discusses how quantitative data are analyzed and interpreted to answer the evaluation questions. Interpreting the data to reach appropriate, defensible, and sound conclusions about the evaluation requires that the evaluation be supported by high quality data and suitable analysis. It means making judgments about the initiative's merits, value, or the worth to the program beneficiaries and the program staff and the community and the funders. So reaching conclusions results in recommendations for decision making about the initiative. The type of data collected during a research study determines the type of analysis that can be undertaken. The data collected in survey research is most often categorized as categorical or numerical. Categorical data could be nominal or ordinal, and some nominal variables are dichotomous and frequently indicate the absence or presence of the characteristic being measured. Examples of pairs of dichotomous variables are healthy, not healthy, well, not well, or sick, male, not male or female. And in this case, healthy may be coded as 1 for the data entry, while not healthy could be coded as 2. So dichotomous variables, like all nominal scale data, have limited options in data analysis. Ordinal variables that are used in ranking the indicator provide for more sophisticated analysis than do nominal scale categorical variables. Numerical data, which could be discrete or continuous data, allow for more detailed analysis than either nominal or ordinal data. And if required, the flexibility of numerical data allows data to be grouped to produce categories and treated as ordinal data for analysis. For example, 20 children whose heights range from 48 inches to 68 inches can be grouped into two categories. The first group could be children 48 inches to 58 inches, and the second group will be children 59 inches to 60 inches tall. So quantitative data can be analyzed in two ways, as descriptive statistics and as inferential statistics. And the initial analysis in a research study produces descriptive statistics, which summarize and describe the entire data. So these measures include frequencies, percentages, and proportions, and measures of central tendency, the mean, the median, and the mode, and measures of dispersion and the range and standard deviation and variance. So frequencies represent the number of times an event occurs or the number of responses, while percentages represent the number of occurrences or the number of responses as a proportion of the whole. For example, if 30 people respond to a survey out of a total of 100, the frequency of respondents is 30, and the proportion is 0.3, and the percentage is 30%. So each question in the survey, however, may have a different denominator for calculating the percentages if all the questions are not answered. If, for example, question number 20 was answered by only 60 people, then the denominator for calculating the proportion and hence the percentage will be 60. Means are the most often used measure of central tendency, and the mean is the calculated average of the responses. For example, if 30 people have scores ranging from 10 to 30, all the scores are totaled, and the total is divided by 30 to calculate the mean. Means are also used to summarize the responses on rating scales. On the other hand, modes are the most frequently occurring response, and medians are the middle value of a set of values with an equal number of values falling above and below. The range is the span between the lowest and the highest scores. Standard deviations represent the variations in the data and the distance that the data points are from the mean. So a low standard deviation indicates little difference between the value and the means of all the values, and a high standard deviation indicates a large difference. When there is no difference, the standard deviation is 0, and variance is the square of the standard deviation. So the first step in data analysis is to summarize the data across all the demographic variables and the survey items. So in this first step, calculate the frequencies, the percentages, the measures of central tendency, and the measures of dispersion. Data analysis can be conducted using data analysis software like Microsoft Excel, SPSS, and Gemovi, or other suitable computer software. So the greater the variability in the data, the more likely it is that the data can be explained and conclusions can be drawn about the relationship among the variables and about the population as a whole. Statistics calculated will be determined by the type of data you are working with. For example, you could do a mean for age because ages are continuous data, but a mean for gender, which is categorical, would be meaningless or rather impossible. And for gender, you would be limited to frequencies and percentages. And so look at the proportion of men compared with the proportion of women in the sample. The results of the analysis can be presented in a variety of ways, including tables, charts, and graphs. In reporting the data, it is not sufficient to use graphs alone or graphic figures alone. They must be accompanied by narratives explaining what they mean to the reader. And so you must have some form of narration. And providing the charts allows readers to also make their own interpretations of the data. So let us see some examples. We'll use some examples to illustrate ways of presenting and explaining data. So this table here shows a single variable table format for presenting quantitative data, and the narration can be presented by stating there were a total of 51 participants in the study, most of whom, in brackets 75%, were male. And this second table shows a multi-variable table format for presenting quantitative data. And this can be reported by saying a total of 160 men aged 31 to 71 years, mean 57.7 years, were included in this study. Most of them, 60%, were white, 25% were African American, and 15% were Hispanic. Most, and that's 95%, were satisfied with the program, with a mean satisfaction score of 4.69 on a 5-point scale, and 94% said they would recommend the program to someone else. And then you conclude by making reference to the table where this data is fully displayed. And here we write table 2. This third example is an example of data presented in a bar chart format. And we could present the data by saying overall, participants were satisfied with all the activities. The mean score for the physical activity component was 4.5. For nutrition education, it was slightly less at 4.0, and participants working with their peers was 3.6. Although there was no significant difference in satisfaction scores between the nutrition activity and the in-gym activities, there was a significant difference, p-value of 0.02, between the in-gym activities and the participants working with their peers. And then we write in brackets figure 3. This fourth example shows data presented in a pie chart format, and the narration could be there were almost equal numbers of participants in the 3 offerings of the initiatives. Figure 2 in brackets. It's important to also mention cross tabulations, which are a useful way to summarize data in bivariate relationships, and they can be used with nominal or ordinal data. And when used with nominal data, the statistic associated with them is the chi-square. But when used with ordinal data, we use what is known as the Spearman's rank or that correlation. So analyzing data from quasi-experiments consists primarily of comparing the intervention group with the comparison group, or comparing the pre and post values for the same group for the outcome variable. And inferential statistics describe the analysis that makes inferences about the data and the population from the sample that is studied. Estimation and hypothesis testing are inferential statistics, where the null hypothesis states that there is no difference between the two groups being compared. If the participants in the sample were not randomly assigned, and the assumption cannot be made that the results are generalizable to a larger population, then inferential statistics may be inappropriate. A commonly used test to assess the difference in means before and after evaluation designs is the paired t-test. The z-test is used to compare differences in proportions, say between a group that has received an intervention and another group that did not. A more in-depth description of these and other statistical tests may be used in evaluation, including other bivariate tests such as the chi-square tests, analysis of variance, ANOVA, as well as multivariate analysis are beyond the scope of this lecture, and but you can find them in your textbooks of biostatistics or research methods. Because evaluation is primarily about assessing the initiative's merits, its worth, value, and the analysis of the data is used to formulate the conclusion. Conclusions are based on criteria developed at the start of the process and on the standards that were established by the evaluation team and the stakeholders. The synthesis of the results of an evaluation study requires the integration of all the results that are obtained from the many assessments that may have been carried out. In addition to the data being interpreted to reflect statistical significance, the data must also be interpreted to reflect practical significance and importance to the stakeholders, in the light of their values and standards. And so developing a summary of the data and the analysis will help in organizing and synthesizing the information. So the aim is to present a balanced report and that discusses the value of the initiative to the different stakeholders and various audiences. And so the value of the initiative may be both tangible and intangible and is assessed using multiple criteria, and that includes relevant information about the initiative, its description and context, the objective, unbiased and systematic research, and performance on indicators of merit in process and outcome measures, and recognize standards and criteria of performance based on comparison groups or other groups or other programs or both, cost efficiency criteria, policies, regulations and laws, stakeholder and community values and expectations, environmental standards, as well as standards of social justice and equity. In addition to being assessed against expected outcomes, the data are also assessed for unexpected outcomes that benefit or hurt the community and the participants or non-participants. So lessons learned from conducting the evaluation are identified, and they pertain to the value of the evaluation, the range of experiences in the research approach, and participant recruitment, and data collection, and the research findings. Assessing failures or shortcomings of the evaluation provides an opportunity to plan improvements in the evaluation process. Members of the community are much less likely to want to be involved in data analysis than in data collection for the evaluation. However, they can play a number of roles and their contributions need not be any less than in any other phase of the evaluation. In the spirit of community-based participatory research and empowerment of the community, it's important that data analysis skills be taught to the community members where possible, and the team may need to bring in new members from the community who are both interested in and have the aptitude to learn the methods. Quantitative data analysis requires background knowledge that usually comes with a higher level of academic preparation. So let us review a process for thinking about an evaluation research study. The evaluator was part of the process from the very beginning and wanted to be sure that the group started out knowing as much as they could about the group before designing an intervention. So for the background, the rates of transmission of sexually transmitted diseases were increasing, again, after a few years of a slow decline, in spite of the fact that a range of educational programs were being offered. And in preparation for another intervention, it was decided to conduct an assessment of the most vulnerable population, the population where the rates of infection appear to be increasing the most. And the assessment was designed to provide information on which to base the intervention. The population of interest was a youthful computer and internet savvy group that used social networking extensively. And because the intervention was to be implemented through a social networking mechanism, the computer-based assessment was conducted using the same site. And the assumption was that the group that got the survey would be fairly representative of the group that would get the intervention. For the methods, the researchers designed a survey that consisted of a number of sections, and they collected demographic data, including age, ethnicity, gender, marital status, state and county of residence, alcohol and other drug use, sexual preferences, sexual risk behaviors, and knowledge and attitudes about practices related to the transmission and prevention of sexually transmitted diseases. In addition, they asked questions about the practicality of using social networking sites to conduct an intervention. The evaluators distributed the previously validated IRB approved survey with a cover letter explaining the extent of the study and provided a link that respondents could click on if they were interested. And within a few days, they received 1,800 responses. With respect to data analysis, the survey generated a combination of categorical and continuous data that were downloaded and transferred into SPSS and checked for entry errors. Discrepancies were resolved and the data were cleaned. The evaluation team calculated frequencies on all categorical variables and the means on all appropriate categories. And chi-square test was used to check for associations between categorical variables. And the level of statistical significance alpha was set to 0.05. And the evaluators were interested in knowing whether the subgroups within the sample differed in any meaningful way. So they created subsamples and compared them using analysis of variance. In terms of describing the data analysis allowed a description of the sample, including a demographic profile and knowledge, attitudes, and practices regarding the transmission and prevention of sexually transmitted diseases. In addition, risk and protective factors were identified, as well as social and political determinants of health. Tables and charts were created to show the characteristics of the respondents and the results of the tests that were run with their corresponding p-values. The results provided researchers with information about the specific characteristics of subgroups within the sample, and significant differences were detected. The 18 to 24-year-olds were significantly different in their risk-taking behaviors from the groups that were 25 to 30 and 31 to 35 years old. In addition, the level of risk-taking behaviors was associated with alcohol consumption, and there was a difference in the type of risk-taking by group and the behaviors that they engaged in. So when it came to interpreting the data, the group with fairly high risk-taking behavior was found to be the college students, and overall they were less inclined to prevention of sexually transmitted diseases and more likely to consume alcohol than those in the older groups. And they were much more likely to believe that a cure was available for each of the sexually transmitted diseases and less likely to believe they were at risk for infection as a result of their practices. Following a full review of the results, and the team decided to design different interventions for each age group. Even though the 18 to 24-year-olds had the greatest risk, the 31 to 35-year-olds exhibited high-risk behaviors that were different but also had to be addressed. Because the largest group that participated in the study was the college age group, the team concluded that the first intervention designed will be for them, and this intervention would serve as more like a pilot program. The team compared their findings with those of other researchers, and they reviewed the literature again to be sure they had not missed any recent papers, and found that although their study had been conducted online, their results were not significantly different from the results of studies that had been conducted on college campuses. And they found it surprising that, unlike previous studies, their study showed no differences among the three ethnic groups that dominated the sample. And this was an especially important finding for the researchers and planners because their intervention would be online and they would have much less control over who will take part. So they decided to institute a password secured site for the intervention. And they knew that young people shared a lot of information with their friends, including passwords to online programs. And so controlling access would be challenging. The team used results about the social, cultural, and political context to guide the development of the intervention and to decide how they would implement and evaluate their work over a 3-year funding period. So, in summary, descriptive statistics summarize and describe the data, frequencies, percentages, measures of central tendency like mean, median, and mode, and measures of dispersion like standard deviation and variance are used for descriptive analysis. The method of analysis is determined by the characteristics of the data and the combination of levels of measurements across the outcome and the intervention variable. And the most commonly used measure of analysis for comparing two groups is the mean. And we can also compare proportion between groups. Data must be interpreted based on criteria developed at the start of the process and on the standards that were established by the evaluation team and stakeholders. Data must also be interpreted to reflect their practical significance and importance to the stakeholders in light of their values and standards. Thanks for watching and see you in the next lecture.